All right, we're doing Leetcode Easy today. It's the valid anagram question. We're just going to get into it. Okay, so given two strings, S and T, return true if T is an anagram of S and false otherwise. So then they define anagram as a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. Okay, so we've got an example here, anagram and nagram. So these are anagrams. Okay, so pretty straightforward, I think. Okay, and case. So as far as case goes, something like that. As far as like case goes, they say that it's always. So I guess yeah, input strings are always lowercase. Lowercase. Okay, and they have a follow-up question. So I guess we can solve it and then maybe solve the follow-up if we have some time. Okay, so got rat, car, false. Okay, so I'm wondering, it seems like if they're of a different length, right, that seems like that would be not an anagram immediately, unless there's some sort of solution where, okay, and you have to use the original letters exactly once. Okay, so if we're thinking, let's just grab these test cases. Thinking like for this one, for anagram, what if it was like anagrams, right? Would this be considered true because you can create this word from using these letters, but you're not using all of the letters. So I think you have, so they say this pretty clearly, typically using all of the original letters exactly once. Okay. All right. So I think this would be false as far as our test cases are concerned. So must use each character in S exactly once in T. Okay. And it's always going to be greater than or equal to, so the string length will always be greater than or equal to 1. Okay. And this will always be less than or equal to that expression as far as length. Okay. Lowercase English letters. So we don't have to worry about, so I guess if we just were to like express, so input, it's always going to be always lowercase, always two lowercase strings of length 1 or more. Okay. Cool. Okay, so there's not really much else to this problem. So I guess we can start thinking kind of about our approach here, and then just remembering that this is returning Boolean. Okay. And this is like a test case we were thinking of. Maybe we just like think of like another one. So this is one. It's like A. That would also be true, but this case A be false. And grab this one again. This would is A. Okay, and then yeah, like this would also be false, just because they're different lengths. So you just maybe write that lang. Then this is just all characters are used. Okay, and they don't really say anything about like uniqueness or anything of the characters, so we don't have to worry about that. Oh, okay, cool. Right, we can just grab this test case as well. Okay, so this is false, and then let's see. And let's just grab the main one too. Just keep them all in mind. Great. Okay, so got all of those, and we've identified some rules. So input will always be lowercase string characters, lowercase English characters. Must use each character in S exactly once. All right, and then always 2 lowercase strings of length 1 or more. Okay, so as far as like our algorithm goes, I'm gonna write out some pseudocode here, and we'll just move this up a bit. Okay, so as far as the first thing we want to do, I think we just want to check if S and T have equal lengths. Okay, and then if they don't, so if not, just immediately return false. False. Okay, so we have that little check at the beginning to account for those situations. And I think I just want to do this with like a set object, I think. So maybe like traverse S and build a set object. Okay. Yeah, build a set object. And then after we've done that, we want to traverse T, traverse string T, and check that every character is contained. So every character encountered is contained within our set object. And so first that, and that the value is, and that the letters value is greater than 0. Okay. Okay, so I'm obviously going to flesh this out a little bit more, but this is the general flow that I would expect. And essentially we're just checking to see if there's ever a character that we encounter that either doesn't have an entry in our set object, or the value associated with the key in that set object for that letter is 0, then we know that we have run into a situation where we don't have enough letters in the in S, so the original string, to build the string T. So okay, so I'm gonna write a little bit of code here. So if S length, and I actually don't like the I'm gonna use like original and original and candidate. Okay, so if original length is not equal to candidate length, then we immediately just want to return false. Okay, and now we want to traverse and build that set object. So I think this is great use case for reduce. So that's what we're going to do. However, we need our in order to use reduce here, I think we need it to be an array. So first things first is just convert the string original into an array representation of each character. Okay, so we're just going to split by empty space. Then we're going to traverse the original array. Original. Really struggling today with that spelling. Okay, and basically what we're going to do is build this set object, right? So we're going to use accumulator and current, and we're going to build that set object. Okay, oops. So we're there. And okay, so we're building the set object. So what are we doing here? Well, we want to check to see that every character encountered. So actually, before we do that, we just need to build the set object. So the first things first, we need to check if character exists already. If so, increment that props value by 1. If doesn't exist, then we want to essentially create that property in the set. So we're just going to add it to add character to set object. So this is just going to be accumulator, and this is going to be current. Okay. And then eventually, since we're using reduce, we just want to return our accumulator. So I'm just going to implement that. So check if character already exists. So that's just going to be if accumulator current. So if it exists in our set object, this is the initial value, so it's a set object. We're checking if that exists. So if it does, we just want to increment the value by 1, so accumulator current plus plus. Else, so this is the circumstance where the character is not yet in the set, so we want to initialize it, right? So first of all, I think I need to think about this. If we're doing this, I'm just thinking like there's slightly different methods for set objects. I think it's fine. So we do accumulator current. Okay. And I think we just need to set it to 1 initially, and then we just want to return our accumulator object. Okay. So I think that makes sense. See, there's probably a better way to do this. Okay, well, we have our set object. So if I were to just like console log our here do a const ridge set. Okay. So let's just log that out. A ridge set. So obviously, we're not submitting a solution yet. I just wanted to see. So original, because I didn't actually use the array, I used the string, so that's invalid. So what I want to see here is just this string represented as a set, which I think we're seeing. Okay, so there's 3 A's. Okay, so then 1 N, 1 M, 1 R, and 1 G. Okay, cool. So that looks good. That's what we expected. So I'm going to bring this down. So we have our set object. So now what's the next thing we want to do? We want to traverse the second argument, t, and check that every character encountered is contained in the set object and that the letter's value is greater than 0. Okay, so I think I'm just going to use a standard for loop here. Let I equals 0, I less than candidate length. Okay, and then increment I. So we have our for loop. And basically, if the character is not in the set, so I guess we need, we'll do const character is candidate at I, okay, and then the next thing we want to do is check that every character encountered is contained in within our set, and the letter's value is greater than 0. So I think I want to do like the inverse of that, or I guess the negation of those two conditions. So if original set character, so if it doesn't exist, okay, I'm a little concerned because 0 is falsy. So it doesn't exist, or the letters. So this could technically be okay, so that could be a problem because I guess I try to verbalize the problem here. So if we try to use this approach and some character, some value in our set. So if we can we go back to, I guess it's gone forever. When we were looking at that set object, the key is a letter character or a string character, and the value was some number. And what I was thinking here was if the character if the character exists but its value is 0, then this could return true, because 0 would be if it's evaluated in a conditional expression, it has a falsy value, or like it has a falsy quality. It is falsy, and so if it's not falsy, then this would evaluate true. So that's sort of a problem with this approach. Let's take a step back. Every character encountered is contained within the set object, and the letter's value is greater than 0. Okay, so if original set character, if it exists and original set character greater than 0, then we can continue. So kind of a useless condition, but I guess we would need to increment. Yeah, so that's actually not useless. So we would want to increment original the value there. So, or I guess decrement orig set character minus minus. So it exists and its value is greater than 0. Decrement the value and continue. And I think this continue is unnecessary. Okay, else. So this is a situation where it's not there. It doesn't exist. Then we would just want to immediately return false. Okay, and then return true. So we're to run curious. Does this work? It works for that test case. Okay, well, I guess it passed. I wasn't super happy with my approach here. It's kind of a little bit janky, a little quick and dirty, but so it goes. This was just kind of a fun problem. I do kind of want to do like a sort of a check to see maybe off camera like what I was concerned with the 0 being evaluated falsy. So yeah, maybe we'll just end the video here. Nice short one. And I'm sure there's like a better way to do this, but yeah, this was valid anagram 242 on Leetcode, and it wasn't particularly fast. I guess slightly decent when it comes to the memory usage. I mean, one way to cut down would just be to do this in a different way, which is like we can definitely optimize that. Like if we didn't want to use reduce, so I guess the memory issue here is we're transforming our original string into an array, so that's where we're losing some memory usage points here. So if we wanted to take a different approach, that would just be something like using a normal for loop, iterating through the characters in original, and then populating some set object. So essentially, we just wouldn't be converting our original string to an array. But yeah, this was just kind of a fun little exercise. And yeah, I'm gonna call it. Thanks for watching. Trying to make these shorter. Peace.